Alright guys, so this is activity 9, lesson 9-1, and it's all about deriving the quadratic formula, and this first part is about completing the square. How do you complete the square, and also taking square roots. And actually we do these in opposite order, taking square roots and then we complete the square. Okay. Okay, so here's our first example. Actually, let me zoom in a little bit here. So here's our first example, which is solve 5x squared minus 23 is equal to 0, and we're going to solve for x. So this is pretty easy. All we're going to do is isolate our x squared. Okay, so when they isolate the x squared, they add the 23 over, and then they divide by 5, and we end up at this point. X squared is equal to 23 divided by 5. And then you can see you take the square root of both sides. Okay. And when you take the square roots of an x squared, okay, you have to say x is equal to plus or minus. Okay, and there's a reason for that. Let me just show you an example. All right, so say you had x squared is equal to 1. Okay, and I'm going to ask you, what are the solutions to this? Well, what squared will get you back to 1? Well, 1 squared will get you back to 1, but also negative 1 times negative 1 is also positive 1, right? Negative 1 squared is also 1 as well. So when I take the square root of both sides, okay, this could have been the x could have been the positive version of itself or the negative version of itself every single time. And that's why we have x is equal to plus or minus the square root of the other side. In this case, it would be plus or minus 1. They don't really show you that there. Looks like they kind of show you over here, but yeah, they don't really tell you why. Okay. So anyway, and by the way, I don't care how complicated this thing gets when you take the square root of both sides. Say for example, it's a little sloppy, but say for example, let me erase all this. Actually, you know what? I want to keep that there. That's why, the plus or the minus. So say for example, you had like something crazy. I don't know, like you ended up with, not the square root. You ended up with, I don't know, x plus 5 squared. All right. I know this isn't that crazy, but is equal to blah, 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 whatever. When you take the square root of both sides, as long as you had anything that was going to be an x squared inside of there, even though this is complicated, you're still going to take plus or minus the other side, no matter what. Whenever you have any x squared underneath this radical, you'll take plus or minus. All right, and that's why, because both the plus and the negative versions work. Okay? All right, so anyway. So continuing on here, they go ahead and say they take the square root of both sides, and which is actually the square root of 23 over 5. And if you're not, hopefully you remember your radical rules here. The square root of 23 divided by 5, whenever you have a fraction inside there, you can then take the square root of the numerator divided by the square root of the denominator. So square root of 23 over square root of 5. However, this is not an acceptable answer because you have a square roots in the denominator or a radical in the denominator, so you have to rationalize, and you rationalize by multiplying top and bottom by the denominator, or that square root, I should say. And you'll end up with square root of 23 times square root of 5 was square root of 115, and then square root of 5 times square root of 5 is square root of 25, which is 5. That's why 5 pops out of there. Okay, anyway, so going ahead and solving these, and by the way, this is how we normally solve. The whole last lesson with the, the whole conjugate thing where you're taking the square roots of both sides and all that, we don't typically do that. Unless there is, unless they ask you to specifically factor it, okay? But when we're just solving, we just go ahead and isolate the x. So let's go ahead and do some examples. All right, so we have 9x squared minus 49 is equal to 0. So let's isolate the x, which would get you x squared is equal to 49 divided by 9. I'm going to take the square root of both sides, which will get me x is equal to plus or minus the square root of 49, which is 7, divided by the square root of 9, which is 3. And there we go. All right, we'll do the same thing here. So here we end up with x squared is equal to 7 divided by 25. Taking the square root of both sides, you will get x is equal to plus or minus the square root of 7 over the square root of 25, which is 5. All right, let's go to the next one here. So here we've got x squared is equal to 16 over 5. So we get x is equal to plus or minus, when I take the square root of this whole thing, you get 4 over the square root of 5. And it can't have that, so I need to multiply top and bottom by square root of 5. So this is going to be equal to plus or minus, don't forget about that plus or minus, 4 root 5 all over 5. And then last one here, we've got x squared is equal to negative 15. That should yield an interesting answer. So negative 15 over 4. Taking the square root of both sides, you'll get x is equal to plus or minus the square root of negative 15 over the square root of 4, which is 2, which is equal to plus or minus, well, I can't have a negative in there, so I'm going to pull out the I, which is I times the square root of 15 over 2. All right, so let's keep going. Compare and contrast solutions to the equations in try these A. So basically what they're going for here is they want to know what's irrational, what's rational, and what's complex or imaginary, I should say. In this case, A would be rational. A rational number can be expressed as a whole number over another whole number, and 7/3 is a rational number because it meets the definition. So this is rational. A is rational. B and C are both irrational because they cannot be, it's the opposite of rational. It cannot be expressed as a whole number over a whole number. You got a square root in there, so it is irrational. Okay, B and C are rational. D would be called imaginary. Okay, because it's got an I in there, or complex. You could call them complex as well. All right, but oops, I would say imaginary because it's got an I in there. Some people might say, well, they're imaginary and irrational because of the square root. As far as I've never heard of. And I don't know why this is, but I've never heard of anybody saying it's an imaginary irrational or an imaginary rational. It's just imaginary because it's in the imaginary realm there. So I've never heard of anybody saying that. So it's, again, if they're real numbers, they're going to be irrational or rational. And otherwise, if they're imaginary, then it's just going to be imaginary numbers. Okay? All right, anyway. Coming down here, so to solve this equation, so this is what I was referring to before, where you might have something a little bit more complex, okay, but it doesn't matter. You're still at the point where you take the square root of this thing right here, x minus 3 squared, all right, you are taking the square root of what would be an x squared underneath there if you actually multiplied it out, so you need to do plus or minus at that point in time. So let's take a look. They isolate. That's always the first step, is to isolate that the x, or the complicated thing that the x is in. So you're going to isolate at this point. X minus 3 squared is equal to 5 halves. So at that point, I can take the square root of both sides. Remember, this x, if I multiply this out, it would be an x squared. So you need to take plus or minus. Okay? Now this guy pops right out of the square root because that's what it undoes the exponent of 2 there. So I have x minus 3, and over here just make sure you apply your plus or minus, and it's plus or minus 5 square root of 5 over square root of 2. And from there you would continue solving for x. So I need to add 3 to the other side. So in this case it's 3 plus or minus square root of 10 over 2. Okay, and that gives you 2 answers. The first version is 3 plus square root of 10 over 2. The second answer is 3 minus square root of 10 over 2. Okay, so let's go ahead and do these ones real quick. So I need to isolate the x plus 5 squared. So x plus 5 squared is going to be equal to 49. I'm going to add that over, and then I'm going to divide by 4. Now I'm going to take the square root of both sides. So this pops out. X plus 5 is equal to plus or minus the square root of 49, which is 7, over the square root of 4, which is 2. And subtracting the 5 over, it gives you x is equal to -5 plus or minus 7/2. In this case, we can continue to simplify this. All right, just because it's a lot of work doesn't mean you can't do it, because this can be simplified. So let's go ahead and move this up here. So x is equal to -10/2 plus or minus 7/2. Okay. The 5 over 1 changed into 10 over 2 to get a common denominator, which means that x is going to be equal to, let's take the first case, -10/2 plus 7/2 would be -3/2. Or it would be the second case, -10/2 minus 7/2, which would be -17/2. And there you go. Those are your two answers. Okay? It's not enough to leave it like this over here when it can be simplified. Okay, next up here, let's see here. Isolate the x squared. So I have x minus 2 squared is equal to 16 over 3. I can tell you this 3 is going to be a problem right away because we're going to have to rationalize. But anyway, we'll take the square root of both sides, giving us x minus 2 pops out, is equal to, the square root of 16 is, I'm sorry, plus or minus. Don't forget about that. So the square root of 16 is 4 divided by the square root of 3. All right, now I need to rationalize this thing. So I'm going to multiply top and bottom by the square root of 3 right away just to get rid of this thing. So square root of 3, square root of 3. All right, so that is equal to plus or minus 4 root 3 over 3. And then I'm going to move my 2 over. So x is equal to 2 plus or minus 4 times the square root of 3 over 3. And there you go. That cannot be simplified any further. Okay, let's see here. So next up, let's isolate. X plus 1 squared is equal to 8 divided by 5. Square root of both sides pops out to x plus 1 is equal to plus or minus square root of 8. Let's see, square root of 8 is 2 root 2. And square root of 5 is just square root of 5. And let's go ahead and rationalize. So I need to multiply top and bottom by root 5. So it's equal to plus or minus 2 root 10. Square root of 2 times square root of 5 is square root of 10 over 5. And go ahead and subtract your 1. So I get x is equal to -1 plus or minus 2 times the square root of 10 divided by 5. And there you go. And the last one here, ooh, this is going to turn it into a negative, so I'm going to have an imaginary number in here later. So let's go ahead and isolate. So I get x plus 7 squared is equal to -25 over 4. At least these are perfect squares. So I'm going to take the square root of both sides, which pops out the x plus 7, is equal to plus or minus, and then I take the square root of both. Square root of -25 would be 5i divided by square root of 4, which is 2. Therefore, x is equal to -7 plus or minus 5 halves I. And there we go. Describe the differences among the solutions. Okay, so same thing here. Which of these are going to be rational? Take a guess. So remember, a rational solution or a rational number can be expressed as a whole number divided by another whole number. So that would be a, -3 halves, -17 halves, whole numbers over whole numbers. Irrational is the opposite of that, if it can't be expressed as a whole number over a whole number. So that would be B and C, because you got square roots in here, and you can't simplify those. And then finally, you've got imaginary solutions, which would be D, because you got imaginary numbers in there. Okay. All right, so let's keep moving on. So now we are getting to completing the square. All right. Completing the square is an extremely useful tool, and it's extremely similar to the quadratic formula. In fact, we use completing the square to derive the quadratic formula, and we're going to cover that in our next lesson. So when do we use completing the square? If if a quadratic cannot be factored, you basically have two options now. Before you only had one option. The one option was to use the quadratic formula. But actually, you can complete the square, and that would work fine as well. So you might ask yourself, well, why would I ever complete the square if I already spent all this time memorizing the quadratic formula and I can use it, and why do I need to learn something else that's more complicated? Well, the answer to that is because not only does it help you solve, but it also helps you put the equation, the quadratic equation, into vertex form, so it is also easy to graph. So you get two things out of it. The quadratic formula doesn't help you graph a parabola, really, not much at all. Okay, but when you complete the square, it does. Furthermore, in pre-calculus for next year, you guys will do tons of completing the square, specifically in a unit called conic sections, where you will have equations for not just parabolas, but also circles, ellipses, and hyperbolas. And with all of those, you will have to be an expert at completing the square because you have to get it into a proper form, vertex form, in order to graph these things. Okay? So again, it's extremely similar. You would use it in the same instances as the quadratic formula, except you get more out of it. All right, it helps you graph. Okay, and in particular, just so you know, we got done talking about absolute value functions before. The parent function for a parabola would be y is equal to x squared. That's the parent. And the vertex form would look like this. Y is equal to a times, and I'm not going to put in the b yet because I don't want to confuse you guys, but we'll just call it a times x minus h squared plus k, like that. Okay, so that's the form we're going for, and you will see that when we, at one point while we're completing the square, you'll see this form pop up. Okay, and actually let's look at our example here. So here we've got this quadratic equation, which is 2x squared plus 12x plus 5 is equal to 0. We can't factor this, so we would go ahead and complete the square. Okay, so the first step in completing the square is to set a equal to 1. In this case, a is equal to 2. So how would I get a equal to 1? Well, I have to divide everything by 2, which makes some fractions. And, you know, completing the square is not the easiest thing in the world, but it's kind of about the same as far as difficulty level of using the quadratic formula. But you have to be pretty decent with the fractions. So anyway, we divide everything by 2. So when you divide by 2, you end up with this guy right here, which is x squared plus 6x plus 5 halves is equal to 0. All right, again, this thing is not factorable, at least not with the methods that we've learned so far. I mean, we've never talked about fractions in here. So what we do is we move this 5 halves over because it's a problem right now, right? It would be really nice if it was x squared plus 6x plus something nice, wouldn't it? Well, that's what we're going to do. That's what completing the square is all about. We're going to subtract the 5 halves over to get it out of the way for the moment, giving us x squared plus 6x, all right? And then is equal to, well, we'll just chuck that number on the other side. That way we can move this over and make room to add a nice number in here. All right, and that is where we're completing the square, okay? Now, since we add a nice number over here to one side, remember algebraically, we always have to add that nice number over to the other side as well, okay? All right, so let's go about doing this. So how do we come up with this nice number? Well, this nice number is always, in this case, RB divided by 2 and then squared. And also, this guy right here happens to be RB divided by 2. So we'll see that when we get there. So first of all, RB divided by 2. Well, 6 divided by 2 is 3, and then 3 squared is 9. So we're going to put this nice number 9 in here on both sides. Now, this guy gives us a really nice factorable left-hand side. So how does this factor? Well, this thing factors as x plus 3 squared. And this guy right here is always going to be b divided by 2. And this always works. It's really nice. It's called completing the square, and it creates this square. That's why it's called completing the square, x plus 3 squared. And if you multiply this out, you get back to x squared plus 6x plus 9. Now, remember, since we added 9 over on this side, we have to add 9 over here, and so that requires typically a little bit of fraction work. So in order to add these together, this 9 would become 18 over 2 to get a common denominator, and then negative 5 over 2 plus 18 over 2 would be 13 over 2, and that's where they're getting this 13 over 2. All right, and actually at this point you can see that you could rearrange this very easily to get this guy right here, our vertex form. All right, in fact, you would just subtract the 13 over 2 over, and it would be equal to 0, and that would be y. So y is equal to x plus 3 squared minus 13 over 2. And then you could go ahead and graph that pretty easily. As long as you know the parent function, you just apply the transformations. All right, but in this case, we're just solving. They don't actually talk about graphing at all in this unit, during this lesson at least. So they're just going to solve from here. All right, now that we have a squared on one side, we will take the square root of both sides like we just did. So the x plus 3 will pop out, and then we have plus or minus the square root of 13 over 2. And then we're just going to, well, first of all, square root of 13 over 2 needs to be rationalized. So we multiply by square root of 2 over square root of 2 to get plus or minus square root of 26 over 2. And then we subtract the 3 over, getting our final solution right here. Negative 3 plus or minus square root of 26 over 2. And if you could check this by using the quadratic formula, it should get the exact same thing. Okay. Again, completing the square, we derive the quadratic formula, and we're going to do that next lesson with completing the square. So they're very, very similar in processes. Okay. So let's go ahead and do some of these here. Let me change back to my blue. And I think there's not a lot of room here, is there? Let me think. Can I fit this in? I don't think so. So let's go ahead and move these over. So let's do A right here. And so the first step is going to be divide everything by 4. So I'm going to be left with x squared plus 4x minus 5 divided by 4 is equal to 0. Hang on one second here. Just move in my other screen. Okay. Let's go ahead and we're going to clear out this nasty thing right here because it doesn't allow us to have a nice perfect square over on the left-hand side. So we're going to add 5/4 to the other side, and I'm also going to create some space. So it's x squared plus 4x. Okay, and the way I write this is I always do something squared like that. All right, I don't put like a box in there. I say whatever this divided by 2 is squared. All right, is equal to, and I guess you could put a box like that, but I always list it like this because, well, I'll show you why in a second. All right, so this is equal to 5/4 plus something else, all right, which is the exact same thing as that. So what goes in here? Well, the b divided by 2 goes in here, right? So 4 divided by 2 is just 2, and so 2 squared goes in there, and I'm adding 4 to this side because that's actually 2 squared, so I got to add 4 to the other side. Okay, so let's go ahead and you'll see why I did that in a second, why I prefer to write it like that. When I factor this, all right, it's always going to end up being x either plus or minus, depending on whether this is a plus or minus on the inside. This is a plus, so it's x plus 2. Whoops, let me put in my colors here so you can see. So x plus 2, which is that b over 2 squared. That's why I like to put it like that, because I just put in the exact same thing. That's what it is. It's already factored, right? Why do the calculation and then try to refactor it again? That doesn't make any sense. All right, is equal to, now this is 5/4 plus 4, but I got to change this to 16 over 4, all right, because I need a common denominator. So 5 plus 16 would be 21 over 4. All right, now I'm going to take the square root of both sides. So let's go ahead and do that. So the x plus 2 pops out, and that's equal to the square root of 21 divided by, oops, I'm sorry, plus or minus. Don't forget your plus or minus. Divided by square root of 4, which is 2, which means that x is equal to negative 2 when I subtract that over, plus or minus the square root of 21 divided by 2. And there you go. There's your answer. All right, completing the square. Those are your two solutions from a quadratic, and we always expect two solutions. All right, so next up here, let's do B, and I think I'm probably just going to do, actually, you know what? I'm just going to write down the answer to B and C, and then we'll come back and do D because that's the only one that's kind of different. And you'll see why. Basically, we're going to end up with imaginary answers here. So B, doing the exact same process, we should end up with x is equal to 3 plus or minus the square root, 4 times the square root of 15 divided by 5. And C, we should end up with x is equal to 3 halves plus or minus the square root of 11 over 2. And let's go ahead and do D together. All right, so D, we'll do that over here. All right, so first of all, again, we need to have a 1 for the A. That's number one problem right there. So we will divide everything by 2. So we end up with x squared minus 2x plus 7 halves is equal to 0. Now I got to clear out that 7 halves to make for a nice number in there. So x squared minus 2x plus something is equal to negative 7 halves plus something. And this something is going to be something squared. Okay, and I'm going to put the actual value over on the other side. All right, so let's go ahead and do that. So that's just this negative 2 divided by 2. So that would be negative 1. All right, so that means that this is going to factor to x minus 1, doing that negative 1 squared, is, oh, I'm sorry, I got to go ahead and add that, don't I? I have to, I added 1 over here. Negative 1 squared is positive 1, so I need to add 1 over here. And when I add 1, that becomes 2 over 2, right? So that would be equal to negative 7 plus 2 is negative 5 divided by 2. And hopefully you guys can see this is going to become imaginary because I got to take the square root of a negative number. Anyway, so I take the square root of both sides. So this is x minus 1 pops out is equal to plus or minus the square root of negative 5 divided by the square root of 2. And I need to rationalize this. So this is equal to plus or minus. I need to multiply top and bottom by square root of 2. So that would be, and I'm also going to pull out the negative as an I. So plus or minus I times the square root of 10 divided by 2. And then we can go ahead and add our 1 over. So x is equal to positive 1 plus or minus I root 10 divided by 2. And there we go. Okay, let's go down now, and I think, yeah, that's it. So I'll do a separate video for the practice problems.